Hello everybody, my name is Paul Ralph, and today I'm going to be talking about the relationship between complexity, process, and agility in software development teams. This project was joint work between myself and a master's student named Eduardo Narros, who did his master's degree at Lancaster University, and he collected all this data and did some really good work with it, so I hope you'll like it. Here we distinguish between a method and a process. A method is the thing that's written in a book. Right? A method is the set of prescriptions as described in the book. The process is what the people actually do in practice, which may or may not be consistent with the method to a greater or lesser extent. This is not a general thing, this is just the way I use the terms in this talk. So we have some kind of uncontroversial relationships here. We know that process affects agility. I'll get into the meaning of agility in a minute, but I don't think anybody would dispute this, that the process that the developers take is going to affect their agility. And we know that complexity affects process. The question is, how does a complexity affect the process the developers take? And the answer to that is more complicated than one might expect. And it also depends on who you ask. So the methods literature is largely split in a debate between so-called agile methods and so-called plan-driven methods. And this obscures a kind of deeper phenomenon, right? So we have this group of methods that ostensibly share a similar philosophy, and we have this other group of methods that don't share that philosophy. But there's more to this. Like, there's a lot more to this, because this is only one way you can break up the methods. Waterfall is a linear method. RUP is not. RUP, the Rational Unified Process, and the Unified Process, which are very similar, are both deeply iterative and parallel methods. To say that they're not agile is difficult. The other thing that's going on here is that there's different meanings of agile, and we'll get to that in a second. A different way of thinking about this is about planning. So agile methods tend to involve a lot less planning in general. The whole idea of planning, they just do less of it. And plan-driven methods have more planning. If you read the literature on agile and plan-driven methods, they agree on something. They agree that agile methods are better for smaller, simpler projects, and plan-driven methods are better for bigger, more complicated projects. But this isn't the only perspective. So there's a theory called complexity theory, and complexity theory is widely used in a lot of different domains. It's used in biology to explain how more simple life becomes more complex life, how simpler life forms evolve into more complicated life forms. It's used in economics to explain increasing returns. Normally when you make more of something you get decreasing returns. But sometimes, like in Facebook, the more users Facebook has, the better it is. So it gets increasing returns, and that's very odd. It took a long time for us to figure out how that worked. Now, in complexity theory, a system is a collection of interconnected components. Complexity refers to the emergent behavior of the system. So normally we think about the behavior of a system as being determined by the behavior of its components. You take a bunch of things, you know how they behave, you stick them together, and the system that they constitute should behave the way the things work together. But it doesn't always work that way. Sometimes when you put a bunch of simple things together, you connect them, they don't work the way you would suppose from the behaviors of those simple things. And that's complexity, that's emergent behavior. So a complex system is a collection of interconnected elements that exhibits behaviors not obvious from its constituent parts. In other words, a complex system is unpredictable. This unpredictability comes from lots of different sources. It can come from nonlinear dynamics within the system. It can come from just interactions that we don't understand very well. So sometimes the complexity is not the system, it's our lack of theory to explain how the system will work. And sometimes it just comes from ignorance. We just don't know how the things put together. Sometimes it comes from the sheer number of components. This is not the normal way complex systems work, but sometimes you have a system that just has so many pieces that we can't build models sophisticated enough to predict how it will work. And sometimes it comes from the unpredictability of the components. Sometimes one of the components is itself complex, We can't predict its behavior, and it sort of throws the whole system into an unpredictable tailspin. Now, complex adaptive systems are a kind of complex system. Here, adaptive refers to the ability to change itself in response to its circumstances. So people are adaptive. We can change ourselves in response to circumstances. Say that I'm 14 years old and I'm a bit pudgy, and I was a bit pudgy when I was 14, and I thought, I'm never going to get a girlfriend like this, so I go to the gym, and I work out hard, and then I get slimmer. And this is changing yourself in response to your circumstances. Computer programs don't do this very well. Programs respond to circumstances deterministically, but they don't rewrite their own code. Okay? That's the adaptive part. So complex adaptive systems is kind of a response to reductionism. Most science is reductionist. We understand more complicated things in terms of their less complicated things. The idea behind complex adaptive systems theory is that you have to understand stuff as a whole thing, and that some of the properties of a whole thing don't come from its pieces directly. Software projects are complex adaptive systems. Sometimes software projects build complex systems, sometimes they don't. It depends on the system, it depends on what you're building. Anytime you build something that's going to be used by people, you're probably building a complex adaptive system. Most of the time, anything that has a direct user interface is going to be a complex system. Sorry, just a complex system, not necessarily adaptive. Now, here's the main implication of complexity theory as applied to software development. Complexity theory says more complexity means planning is less useful. The more complex the system, the less useful it is to plan because the system's unpredictable. So the more complex the project, the more unpredictable the project, and the less useful the planning is. So this sets up an interesting conflict. The methods literature says the more complex the system, the more important it is for us to plan out what we're doing. And complexity theory says the more complex the system, the less useful the planning is, because you can't predict what's going to happen. Now, how does this affect agility? So, agility is a widely misunderstood thing. Or maybe it's not misunderstood as much, it just has multiple meanings. So we think of agility as a property of methods. We talk about agile methods. Those methods are agile. They are agile to the extent that they manifest the agile philosophy. The property of a method is about how much is this method consistent with this philosophy of putting people first and valuing code over documentation and stuff. And then there's this other agility, which is a property of a team. So a team's ability to respond quickly to change is its agility. And we hypothesize, not me, but our community as a whole, hypothesizes that more agile methods will lead to greater team agility. I have yet to see any evidence that applying agile methods actually leads to team agility. That's what we all assume, but that's not really, I don't know if there's any real evidence of that. Now, here I'm talking about the agility, the property of the team. I'm not talking about the agility, the property of the method. I'm talking about how well teams adapt and respond to change. Note that agility implies the team adapts. This is consistent with the complex adaptive systems thing. Anyhow. So, we did a case study. I want to tell you a little bit about the case. We did a case study of a local design agency in the UK. We found they call themselves a design agency because they do sort of combination marketing and system development work. They do a lot of website design, basically. Most of their projects are quite small. Their largest projects only involve 5 or 6 people, but could go on for a long time. A lot of their projects they do in a couple of days. You know, there's a static content website that you make for somebody. One person makes it in 2 days. That's why they call themselves an agency, because they do this really quick stuff. They have something interesting. They have what you might call hub and spokes teams. So when I say a hub and spokes team, most of us, most of the time, think about development as something where you have a team of so many people and they build something, right? They build this one thing and they spend all their time building this one thing. But small design agencies don't work that way. Small design agencies can't work that way because they do a series of small similar projects, not work on one thing for a very long time. So they tend to have this hub and spoke structure where a project is assigned to an account manager or a project manager or something of that nature, and then that person will divide up tasks and send them off to whoever can do them. Often you have some roles which you don't have a lot of people to do them. So you might only have 2 graphic designers out of your 50 employees. So all the graphics work has to go off to them. So they're on all the teams, right? And if one of them goes on vacation, then one guy is on every conceivable team. So this is a bit different from our usual context. Here we studied 2 projects. This was very tricky because we wanted to get a small set of people that were going to be involved in 2 different projects, the one that was more complex and one that was less complex. And we found we found 2 projects that had only one person in the difference. So they had the same graphics designer, the same account manager, the same front-end developer, but they had 2 different lead developers. We had a lead developer on Project A and a lead developer on Project B. The interesting thing about this team, and the reason we wanted to study it, was that they had no imposed method. Management didn't care what they did. They weren't required to make any kind of document. They weren't required to have any particular process or produce anything. All they cared about was if the customer's happy and they pay the bills, that's good. And if the customer's unhappy and don't pay the bills, that's bad. That's it. Otherwise, they just let these guys organize stuff however they wanted. And so we thought that this was going to be a great revelatory case. We thought this would be a case that would be unlike things that were studied before and might get something really interesting out of it. And we did. So we went in for 6 weeks of observation. That's every day, not once a week, every day for 6 weeks. We got all of the emails pretty much. We could have missed some, their emails. But there were no emails where they said, well, you can't look at this one. They just, here's everything, right? We got all the emails, all the technical specifications and proposals and documents associated with each of the 2 projects. And we interviewed all the people involved and the managing director and a few of sort of up and ups in the company and whoever would talk to us, really. Now, then we did some open coding. This is just the normal thematic synthesis kind of open coding that everybody does in interpretive work. And this is what we came up with. So there were 2 projects. Project A was a simple project, and Project B was the complicated project. I mean, Project A was simple in the sense that it was very similar to things that the company had done before. There weren't any real surprises. There wasn't a lot of client involvement. The client basically just said, I want something like this, go figure it out. It followed a very plan-driven, linear, document-centric approach, as far as we could tell. Project B was different. When Project B started, it seemed simple. It seemed like every other, back up. Project A was a relatively static content website. It just had a lot of static content. Project B was an e-commerce site. It sold glasses, like eyeglasses. Project B started out, it seemed very simple. It was same thing, plan-driven, linear, document-centric. It was based largely on a proposal and then a technical specification. So the proposal was a first kind of shorter document that they used to liaise with the client, and then they did out a big technical specification that included the major design decisions, basically. And then they went on and started to build the thing. But unlike Project A, Project B involved a lot of client involvement. The client in question was somebody who was, I would say he was independently wealthy, and he had decided that he was going to retire from his work and do something new. So this was his baby, and he thought about this website all the time. Every day he was working on some aspect of it or thinking about it. He was constantly on the phone with the development team, constantly in with new ideas, changing what he wanted. He was a very dynamic client. Now, as the project went on, the team realized that this project isn't simple. And it's not like things we've done before. We've never had this before. We've never had this client who wants to talk to us all the time. We've never had something that changes this much. We've never had something that's this unlike what we were doing, because the client kept imagining sort of new features. He imagined this feature where you could virtually try on glasses. Virtually trying on glasses is really tricky to implement because everybody's face is really different. It's a lot easier to do virtual trying on of clothes on a website because you can kind of make a mannequin And maybe you have 3 variants and shapes of mannequins, and then you're done. But faces aren't like that. So this became this really one of the really tricky, novel features of this system. And they'd never built anything like this before. So they scrapped their plan-driven approach. They scrapped their linear approach. They brought in a much more adaptive, iterative approach. More specifically, as the perceived complexity of project B increased, the team abandoned the spec. They just threw it out. They renegotiated the contract. They had originally had a fixed price, fixed schedule contract. They went back to the client. They said, look, you need something different. You're changing stuff every 5 minutes. Clearly, we need an ongoing contract. They switched from we're going to build it and deliver it to 3 to 4 week iterations. They brought in monthly reviews where they had the client in and did a demo for them and showed them where they were. They brought in monthly face-to-face meetings. They replaced the spec with sort of short change description documents, kind of like user stories, sort of 1-paragraph descriptions of what the client wanted to do right now. They brought in iterative acceptance testing. So as they had a new release, before it went public, they'd put it on a test server and and do some acceptance testing with the client, allow the client to look at and work through the new site or the changes to the site before they released it publicly. So this is kind of interesting. Here we have 2 teams. Oh, sorry, we have 1 team with 2 projects. A simple project and a more complicated project. For the simpler project, the team used a plan-driven approach. For the more complex project, the team used a more agile approach. As the more complex project became evidently more complex, the team did explicit things to make themselves more agile. They didn't have a methods consultant who said, you need to adopt Scrum, or you need to bring in extreme programming. That didn't happen. What they had was a team that was attempting to do a plan-driven approach, had no formal training in methods. It wasn't working. They perceived the complexity to increase. They perceived the inadequacy of their current methods. And so they took specific steps to change what they were doing to make themselves more adaptive, more reactive, more responsive, more agile. The steps that they took are somewhat consistent with the literature on agile methods, but as far as I know, none of these guys ever read a book on agile methods. As far as I know, none of the interviewees ever read Kent Beck's book on extreme programming and said, oh, we should do this stuff. That's not what happened. They just did this stuff kind of naturally. So, in conclusion, we have the methods literature and the complex adaptive systems literature, and they imply different things. The methods literature says as complexity increases, then we should do more planning. Complexity literature says that as complexity increases, we should do less planning. In this case, when complexity increased, they did less planning, which is what the complexity literature suggests. That doesn't mean everyone will do it this way. It's just what they did in this case. And we thought that was interesting. Set some implications. This is what this study suggests. There were no large projects in this study. Okay, to be clear, even though this project was large for that team, it wasn't large by comparison to the vast scope of projects done on Earth. What this says is that the existing methods literature is conflating complexity with size. Heavy plan-driven methods like the rational unified process aren't for large complex projects. They're for large simple projects, large predictable projects. Waterfall actually works, but only if the project only takes 1 day and is done by 1 person. Waterfall works with very small projects, very simple projects. Does not work with complex or large projects. And it suggests that agile methods are appropriate for small complex projects. Small in the sense that they take 5 people a year to complete. That's a relatively small project. But they're complex, they're unpredictable, things are changing. That's where you use agile methods. You can't use plan-driven methods, well you can, but you're unlikely to be successful using plan-driven methods in complex projects because the complexity undermines the planning. But if you try to use agile methods in very large projects, the level of coordination required exceeds the exceeds the scope of agile methods. They're just, you can't do Scrum with 1,000 people. You just can't. Because you can't have a daily stand-up meeting with 1,000 people. That's not going to work. It's going to take all day. It just doesn't work. So it's not that there's something wrong with them. It's just that they're not built for that. So we don't know what to use for complex large systems. That's probably why so many complex large systems fail.